So let's do 3 problems today where we verify a trigonometric identity. So 3 problems. Here we go. So let's say we have to verify the following identity. Let's see, does this work? Excellent. So let's go with right here. Let's show that sine of theta times the cotangent of theta plus the tangent of theta. All of that simplifies to give you back in return secant of theta. So let's verify and establish this trigonometric identity. Maybe what we can do is distribute the sine of theta. So that'll give us sine theta cotangent theta plus sine theta tangent theta. Now we know that sine can stay sine, but cotangent that can become cosine over sine, right? Plus, let's keep tangent the same, multiplication. And now let's turn tangent into sine over cosine. What else? Maybe we can just call this, oh, how about here? How about here in red? How about here in red? These cancel, right? Those in red, those can cancel out. So we're left with cosine theta over 1 plus sine squared theta over cosine of theta. Let me get this out of the way. There we go. Right, and we got sine squared because it was sine times sine, and cosine's in the bottom. So now we have a fraction plus a fraction, but the denominators are way different. So let's establish a common denominator. So let me switch colors here. And in red, we can get a common denominator of cosine theta. So here, that'd be cosine times cosine, which produces cosine squared. So we would have cosine squared over cosine plus sine squared over cosine. So now we have a common denominator, so we can combine the 2 fractions into 1. And so that would go cosine squared theta plus sine squared theta over cosine theta equals blank for now. Now look at this numerator. We know per our trig identities that sine squared plus cosine squared is 1. So we're left with 1 over cosine theta. And the definition of 1 over cosine, right? One of the definitions for 1 over cosine is literally secant of theta. So just check that off because it matches what it was supposed to match from the very get-go. All right, now let's try this one right here. Let's show that sine theta plus cosine theta, all of that squared, that's supposed to be able to be cleaned up and to give us back the sine of 2 theta. Let me just put some parentheses there if you want, like that. Well, on the left, I see the exponent of 2. So I'm going to write that thingy twice and expand it. So we can go sine theta plus cosine theta times itself because it's being squared. And now we can apply the distributive property. Maybe they called it FOIL in high school. It's just the distributive property. Let's go. So sine times sine gives us sine squared. Sine times cosine is literally that. Sine times cosine. The inside gives you back the same thing, sine times cosine, and then cosine times cosine is cosine squared. So let's see now. How about in the middle, you collect like terms. I have 2 of the same object. So this can go sine squared plus 2 sine theta cosine theta plus cosine squared theta. Oh, and you know what? As I'm looking at my paper here, as I'm looking at my paper, the problem was supposed to say this. I forgot the one. The problem originally, this is a typo on my end. The problem was to say +1. Make sure you have that pink +1 at the end. That's what it's supposed to equal. I didn't even see that. All right, so it doesn't really change anything. Let's keep going here. So it doesn't change what we've done so far. So now we're at this point here. We took the square and we wrote it twice and we expanded. How about this purple team? How about that piece combined with that piece? That purple team, sine squared plus cosine squared, we know that famously gives us back 1. So this is going to be 1. This is going to be 1 plus 2 sine cosine. Now, if you just sort of take a sneak peek at the right-hand side, the ones are supposed to match, and they do. But somehow, some way, this is supposed to become that, if we just compare the left with the right. And that's when I want you to look at your cheat sheet, your trig IDs, look at the double angle section. Look at your double angles, because your double angle will tell you that 2 sine cosine is equal to sine of 2 theta. Check that off, because the left matches the right. I guess if you want technically, instead of 1 plus sine, you could call it sine 2 theta plus 1 to make it perfectly match the right-hand side. Before we do that, I want you to go pencils down and just watch. Let me make a point here in yellow. I want to communicate something here. So if I have x plus, I want you just to watch. If I have x plus y squared, I can show that if I write it twice and FOIL it out, right? If I go x plus y times x plus y, and if I do all that, you're going to get back x squared plus 2xy plus y squared. So if you ever see something that looks like this, it follows this format. You square the first piece, you square the last piece, put them as the bookends, and in the middle, you put 2 and then x times y, okay? Or vice versa. If you see something that looks like this structure in green, you can reverse engineer and write it to look like this as factorized form. Because we might see something in this last problem. We might end up with something that looks like this. And if we do, I want us to comfortably go from there and to rewrite it like this. So just heads up, it might happen. All right, now pencils up. Let's finish this lesson here now. Let's show that 1 plus sine over 1 minus sine is supposed to equal secant theta plus tangent theta squared. We want to go from left to right. Now, if you look at the left-hand side, they kind of look the same, right? They really do look the same, just one positive, one negative. These objects are called conjugates, where they're the same terms, and it's just the only difference is the operation in between. They are called conjugates. And a lot of times when you're doing these trig verification exercises, when you have conjugates, here's a trick that often works. You see the denominator? I'm going to multiply the denominator by its conjugate. So I'm going to multiply the bottom by 1 plus sine. Okay, that's what I'm going to do. However, I can't just do that and get away with it. Whatever I do to the bottom, I do exactly the same thing to the top. So I'm going to multiply the top by the same object, right? The exact same thing. And now what I'm going to do is protect it like that. Let's protect everything. And what I'll do, what we can do is maybe we can FOIL everything. Right? Maybe we can FOIL tops and bottoms. Just expand everything completely, both top and bottom, and let's see what happens. So in the top, if you expand it, you would get back 1 plus 2 sine plus sine squared. I think the lights just turned off. Let me move around so it detects me. We're back. Now in the bottom, if you expand the bottom, which is a difference of squares, you would get 1 minus sine squared. Okay, so that's our first step. Use the conjugate of the bottom, and then just FOIL everything. Now, in the denominator, we know here in yellow that sine squared plus cosine squared equals 1, famously. But if you were to move the sine squared block to that side, you would see that it says that cosine squared equals 1 minus sine squared. So here in the denominator, that matches perfectly. So I'm going to take the denominator and replace it with cosine squared because they are equal to each other. Okay, so let's make that substitution. The bottom is going to become cosine squared. Let's make that change right now. Turn the bottom into cosine squared. So we have 1 plus 2 sine theta plus sine squared over cosine squared. Now, I know this is one fraction, but couldn't we go in green and tear up this one fraction into 3 separate fractions, all of which have the same denominator? Let's make that change. Let's rewrite this as 3 separate fractions. So this would become 1 over cosine squared plus 2 sine over cosine squared plus sine squared over cosine squared. Everybody gets cosine squared. Just separate it. Now the first term, this guy, 1 over cosine squared, that is the definition of secant squared. In the back, sine squared plus cosine squared, that is the definition of tangent squared. Now look at this middle block. See that? Let me actually focus here with the green color. I want your attention to be there. I want us to focus on that while I grab an eraser and I erase some of my previous work. Okay? Let me get rid of some of this here. I want you to look at the green. Let's focus only on the green for now, okay? As we finish this problem in this video. Let's look only at the green. So that says, let me go to a pencil here. We have sine over, now the bottom says cosine squared, which is nothing more than cosine times cosine. And I can put it times 1. Let me break this apart as sine over cosine times 1 over cosine, right? Sine is in the top. The 1 is free. It's still there. Bottom is cosine squared. That's cosine times cosine. That's exactly the same. Now, sine over cosine, that's tangent. Now, 1 over cosine, that's secant. And that's the change I want to make now as I go back to this middle piece here. I have to keep the 2, which is just chilling there, and it's been chilling all along. The 2 is there. But this green bubble gets replaced by this, tangent secant. Tangent theta, secant theta. And now, before we started this last exercise, I prefaced it with a little demonstration. And look, it happens here now. I have secant squared, tangent squared, and in the middle, I have 2 of tangent times secant, right? So that perfectly matches what we had before. So what I'm saying is this can be factorized to become secant theta plus tangent theta quantity squared, right? Because we said earlier that x squared plus 2xy plus y squared becomes x plus y squared. That is exactly what just happened here, right? Secant squared, tangent squared, and in the middle, 2 of their product. That is exactly what this and these are, right? This guy here looks exactly like that. And so we can rewrite it to look like x plus y squared, which is what this says. And that's perfect because it perfectly matches the right-hand side. Are you going to see this level problem on your midterm number 2? Well, honestly, probably not. But it's nice to know how to do these problems, right? So if you guys have any questions about anything at all, just let me know. But if not, have a great weekend, and I'll see you all on Tuesday night.